Go ahead and get started. So now we're going to do the parametric functions. Okay, so the parametric functions, this is something that often confuses you guys. It is probably out of all the chapter 1 elements, it is probably the ones that you guys struggle the most on, okay? Right. We've done this before, obviously, the parametric equations or parametric functions, right? So a parametric equation, so there is a thing called a relation. Does anybody know what a relation is? Relation versus a function, right? Function is what? How do you determine whether something is a function? It has to pass a certain test?
Vertical line test.
It has to pass a vertical line test, right? So if you do not pass a vertical line test, it is basically a relation, right? It's a relation, right? So let's, if you had a circle, like this, right? It's not gonna pass the vertical line test, right? Neither is gonna pass the horizontal line test. So this is not necessarily a function, this is a relation, okay? That's the difference between a function and a relation. Okay, so let's look at example number 1. Example number 1, it says graphing the function. Describe the graph of the relation determined by such and such. Indicate the direction in which the curve is traced. Find a Cartesian equation for a curve that contains a parametrized curve, okay? So first of all, let's step back and let's talk about what a parametric curve is. A parametric is where you describe the relation between x and y, but you describe that by using a third parameter, usually t. It is the t, and you would use t to determine to define the relation, to define the two x and the y, okay? All right, and the reason why we usually use t is because t is usually time, right? We're usually tracing something as a function of time and see how it goes, okay? So let's do example number 1. Where we have x is equal to root t, y is equal to t, I believe, and t is greater than 0. Okay, t is greater than 0 is kind of a dead giveaway that we're talking about time, because time, you don't have anything called, you can't have a negative time, right? Okay. Okay, hang on. Is there anybody waiting in the waiting room here? Huh, how would I know if there were? Okay, I guess not. Never mind. Okay, all right, so we have this. So we need to try to basically eliminate the t to find out what the relationship between the x and the y is, okay? All right, so the way you would do that would be what? How would I go about doing that? I could do it, I could put the t, since y is equal to t, I would just go ahead and plug it in, right? So x is gonna be equal to root y. I would square both sides. X squared is equal to y. So this is the same thing as y is equal to x squared, which looks like this, okay? So if you end here, you do not get full credit because there was an implied t is greater than or equal to 0, which means that x also has to be greater than or equal to 0, right? There's no way that x is negative, right? Because it's a radical over here, so x must be greater than or equal to 0. So your actual graph is going to look like this. You are not going to have the left-hand side. You're going to have the right-hand side only, okay? In other words, so t is equal to 0, starts here. If you trace the graph, it's going to go up like that, okay? So that's how that would work, okay? So in the middle of page 29, there is a definition there, a green box, which defines parametric curves, parametric equations. Okay. So you can look at that. Okay, so flip the page and we'll go to circles. Circles. Okay, so circles using a parametric, well, let's go ahead and just do a normal circle. A normal circle would look like what? A normal circle would be x squared plus y squared is equal to 1, or r squared or something like that, right? This would be a normal circle, right? Okay. Now to parametric, if you parametrize this, you get x is equal to cosine t, y is equal to sine t, and this is what you would get, okay? And the reason why this works is if you plug this in, what do you get? You get, so what do I get? I get cosine squared t plus sine squared t, which is always going to be equal to 1. So yes, indeed, this is a circle, right? Okay. So let's go to example number 2. So if you wanted to, okay, so let's go from here, and if you wanted to draw a circle that had a radius of a, you would just add the a in front of here, right? You would add the a in front of here and in here, and so you would have a squared here, and you would have a squared here, right? You would add these together, and then it would become a squared cosine squared t plus sine squared t. This again is going to be equal to 1, a squared, right? So that's how that would work. So let's look at example number 2, graphing a circle. Describe the graph of the relation determined by, so in your example number 2, you have x is equal to 2 cosine t, y is equal to 2 sine t, right? And yeah, if you just go ahead and do it out, what do you get? You get x squared plus y squared is equal to 2 squared cosine t, 2 squared plus 2 squared sine squared t, 4 cosine squared t plus sine squared t is equal to 4. So you get a circle where the origin is the center, and you have a radius of 2, right? A radius of 2, okay? Ellipses. So the way you would change this to make it be an ellipse is that you would go ahead and change one of these. Because a circle is really an ellipse, it just happens where the semi-major and the other one are the same, right? So you have, if this was 3, right, the way you would work this is this. You would go, well, cosine t is going to be equal to x over 3. Then y over 2 is going to be equal to sine t, right? And this squared plus this squared is going to be equal to 1. So then I would say x over 3 squared plus y over 2 squared is going to be equal to 1. So I'm going to get x squared over 9 plus y squared over 4 is equal to 1. And this kind of stuff should ring a bell when we did the conic sections last year towards the end of the semester. Okay, so that's how you draw an ellipse. All right. Are there any questions of what we talked about so far? Are we good? Any questions? All right, we'll go ahead and take a break here. Oh no, we won't take it. Hang on a second.